matrix is everywhere. It is all around us, even now in this very room.
Today, we're diving into one of the most mind-bending topics in science and tech, quantum computing. And here's the kicker. Google has just announced a breakthrough so big, it could rewrite the future of computing. Stay tuned as we unravel the secrets of quantum computing, explore why this matters, and discover how Google's new chip is changing the game. First, let's understand the basics. Traditional computers work on bits, the zeros and ones that form the backbone of all digital information. These bits are like tiny switches that can either be off, 0, or on, 1. It's straightforward, but limited. Quantum computers, on the other hand, use qubits. Here's where it gets weird. Qubits can exist as 0, 1, or both at the same time, thanks to something called superposition. Imagine flipping a coin that lands heads, tails, and on its edge, all at once. This ability allows quantum computers to process massive amounts of data simultaneously. They also harness another quantum quirk called entanglement, where qubits become interconnected. Change one and the others react instantly, no matter the distance. Einstein called this a spooky action at a distance. And it's the secret sauce that makes quantum computing exponentially powerful. Great, but why does any of this matter? Traditional computers, even the most powerful supercomputers, struggle with certain tasks. Things like modeling complex molecules for drug discovery, simulating climate change, or optimizing vast networks like traffic systems. These problems are so complex, they'd take classical computers millions, or even billions, of years to solve. Enter quantum computing. With its unique abilities, it can tackle these challenges in hours or minutes. Imagine designing next-gen materials, solving logistics puzzles, or even cracking encryption. The possibilities are mind-blowing, but building a quantum computer isn't easy. Qubits are incredibly sensitive. They require temperatures near absolute zero to function and are prone to errors from the slightest interference: heat, electromagnetic fields, even cosmic radiation. This is what we call quantum noise. To scale up quantum systems and make them useful, scientists need error correction. Without it, adding more qubits just increases the chaos. This is the bottleneck that's held quantum computing back for decades, and that's where Google's breakthrough comes in. Meet Willow, Google's latest quantum chip. It's not just another quantum processor, it's a game changer. Willow addresses the scaling problem by reducing error rates as the number of qubits increases. This means scientists can finally add more qubits without the system spiraling into noise. Google tested this chip using a method called random circuit sampling. The result? Tasks that would take classical supercomputers longer than the universe's age to complete were done in minutes. This is a massive leap toward achieving what's called quantum supremacy, when quantum machines outperform classical ones. So what can we do with this power? Quantum computers could revolutionize industries. In healthcare, they might model drugs to cure diseases faster. In energy, they could optimize solar panels or design batteries that last far longer. Even logistics companies could use quantum optimization to slash costs and reduce emissions. We're not just talking about solving math problems, we're talking about solving humanity's biggest challenges. Google isn't alone in this race. Companies like IBM are also making strides, focusing on increasing qubit fidelity, basically how accurate their calculations are. But Google's Willow chip puts it ahead in the race to build commercially viable quantum computers. That said, there's a long way to go. Quantum systems still need better error correction and scalability before they become widely usable. And there are big questions about how governments and industries will regulate and integrate this technology responsibly. We're standing at the edge of a quantum revolution. Google's Willow chip is a beacon of progress, showing us what's possible when science and technology push the boundaries. But what's your take? Are we ready to embrace the quantum future, or do we need to pump the brakes? Let me know in the comments below. And don't forget, subscribe and hit that bell so you never miss an update.